Welcome to another episode of MageCasts.io. In this screencast we will look at this PHPSpec and how we can use PHPSpec to enhance our development workflow. What is PHPSpec? PHPSpec is a development tool from the XUnit family designed to help you write clean and working PHP code. By using a technique derived from the test-first development approach called behavior-driven development, or BDD. This technique is also sometimes referred as Spec BDD, due to the fact that we primarily start describing the behavior of our code before we actually write any part of it. Strictly speaking, there is no real difference between Spec BDD and traditional DDD, but provide the same set of core features and concepts. However, Spec BDD changes the language we use to define and describe our testing scenarios. With Spec BDD, and for that matter PHPSpec, our main goal is to keep focus on the behavior and design rather than in the verification and structure of the inner workings of a given piece of code. Over the course of this screencast, we will concentrate on introducing PHPSpec and its workflow, and as such, we won't dive into Magenta-specific code yet. Our target here is to create a simple example class and get a better understanding of the tools we're using. Now that we have a better understanding of what PHPSpec is and how it's supposed to work, let's fire up our terminal, get our hands dirty, and see what PHPSpec is really capable of. For this example, we assume that you have a working Composer installation and that you're comfortable working with it in the terminal. If this is not the case, please visit getcomposer.com before proceeding. Let's create a new project and the matching Composer file. We will use Composer to install PHPSpec and any other libraries we might need for our project. The first thing that we need to do is tell Composer to require PHPSpec only for our development environment. In this case, we're also telling Composer to load any versions newer than 2.1. Next, we will set up the binary directory to be located in the root of our project. This is more by convenience than a standard practice. This small change in configuration will allow us to run PHPSpec with ease and from the root of our project. Without it, PHPSpec will be installed in the default Composer vendor path. Once done, let's save our Composer.json file and run the Composer install command, and let Composer do its magic. As soon as Composer finishes installing, we can confirm that everything is working correctly by running the following command: bin phpspec run. As we can see, PHPSpec was installed correctly and working as expected. Currently it's reporting 0 specs, 0 examples defined, and a total time of 0 milliseconds. Now that PHPSpec is installed and working correctly, we can go ahead and describe one of our classes. Yes, I said describe. As we said before, PHPSpec is part of the Spec BDD family. The main difference from a traditional DDD approach is that we will be describing our code public behavior, not necessarily its function. Back in our terminal, we will use the aptly named command describe. So let's go ahead and describe an example product class for this example. Let's put it under MageCasts.product, and we will do this by calling bin phpspec describe MageCasts/store/product. The describe command generated a product spec class inside our spec directory, and this is the file that we will use to define all our test scenarios. And let's follow up that by running PHPSpec again. Code generation is one of the hidden gems of PHPSpec that people don't mention enough. Let's say yes and let PHPSpec create the class for us. After generating the class, PHPSpec will try to run the same test again. Wait, there seems to be a problem since PHPSpec is asking to generate the class again for us. Let's reply no this time and try to figure out what happened. What happened? Well, we missed a critical step while configuring our extension. We forgot to specify the namespace, so PHPSpec doesn't know where to look when we are trying to load our product PHP class. Fortunately, this is very simple to resolve. Let's go ahead and open our composer.json file once more. We will make a simple change and specify the auto-loading path for this specific project. We can define this by creating an autoload node, defining the standard for our autoloader, in this case PSR0, as well as the namespace and the directory where it maps to. By default, PHPSpec places all source code inside the source directory, and this is what we will use for our custom namespace. Once we're done, we can go ahead and save the composer.json file. As well, we will require to refresh the autoloader cache in Composer by running composer dump autoload. Finally, we can go ahead and run PHPSpec one more time. And if everything went correctly, we should see green. Our first test is passing. Before moving forward, let's do a quick recap of what just happened. So not only PHPSpec was smart enough to create the test class for us, but it also generated a test subject class. By that we mean the class that we're testing. As you can see, this is a very powerful workflow, one I personally enjoy to create link. If you were paying close attention, you probably noticed that PHPSpec did something else for us. It generated an example spec. Let's take a closer look at what this test is doing. Using our favorite editor, let's open the products page class that can be located under Spec, MageCasts, store PHPSpec.php. As we can see, PHPSpec generated a function called itIsInitializable. This is one of the internal PHPSpecs functions. For now, the only important thing to know is that this function checks for the existence of our subject class. Since we have the spec class open, let's add some additional tests. In a spec class, all test functions must start with the it or it is prefixes. So following the SpecBDD approach, we're going to describe the product class behavior. If we think about it for a second, how should our product behave? We know that products should have a name, and for that we're going to write a function. It should have a name. And inside that function, we're going to say that when getName is called, the product class should return test product name. We also know that a product should have an SKU. As we did before, we will generate a new function called it should have an SKU. And inside that function, when getSKU is called, the product class should return the value of 1, 2, 3, 4, 5. Before we keep moving forward, let's take a closer look at what the tests are doing. A lot of people get confused at first with the use of the this variable inside the spec class. When the test is executed, this is actually referencing a reflection of the subject class. Let's go ahead, save our file, and run PHPSpec once more. And again, PHPSpec code generation features to the rescue. It's not only detecting that the product methods haven't been implemented, but it's also offering to generate them for us, to which we're gonna say yes, of course. Once PHPSpec has generated the dummy methods, it will try to run the test again. In this case, we should get one passing test, our initial test, and two failing ones because we haven't implemented any logic for retrieving the name or the SKU. Now that we have two failing tests, we can go ahead and write some real code. So let's go ahead and open our product class. It can be located under source, mage, store, product.php. As we can see, the class has two dummy functions that were generated by PHPSpec, getName and getSKU. In a real-world scenario, we more than likely would want to retrieve the name and SKU values from some sort of storage, like a database. But for the purpose of this screencast, we're going to store them as class properties and set them through the class constructor. Our first step will be to implement the function logic for each of our methods. getName will return the property name, and SKU will return the SKU class property. we will also need to add the corresponding class properties. We will also need to create our class constructor. In this case, the constructor will take two variables, the name and the SKU, and assign them to the matching class properties. Let's go ahead and save our file, and now we can run PHPSpec one more time. Perfect. We have two failing tests. Since PHPSpec is not setting any values when creating the class reflection, name and SKU will default back to the empty strings. In fact, the PHPSpec errors are actually giving us a great level of detail on what happened and why the test failed. Let's go ahead, open our test, and let's make it pass. In this case, it's as simple as passing the required values to our product class constructor. This is also the perfect time to introduce two PHPSpec functions, let and be constructed with. First, let's take a look at let. For those familiar with PHPUnit, you can think of the let function as the setup equivalent. It will run before each test scenario, and it's a convenient way of working with constructors or doing any kind of setup before the test runs. Inside our let method, we will be using the beConstructedWith function to pass the required values like so. beConstructedWith is one of the internal PHPSpec functions that allows us to interact with our subject class constructor. For now, the only important part to understand is that it will take any variables and pass them to the subject class constructor during the reflection phase. Finally, we can save our spec class and run PHPSpec one more time. This time we should only see green all our tests passing. With this, we conclude our introduction to PHPSpec. As we learned, PHPSpec is a great tool that brings new life and a fresh approach to TDD in PHP. We also learned that PHPSpec is easy to set up, it writes the specification for our objects, and it allows to test in isolation through mocking. However, in this first screencast, we have only touched the surface of PHPSpec. In the upcoming screencast, we will explore some of the more complex parts of PHPSpec in detail and how those relate to Magento development.